Hello, and in this video we're talking about transforming graphs and specifically translating them. So if you think about your transformations that you can do, reflecting, rotating, enlarging and translating, we can do that with a graph. A whole graph we can move around, and it works in a very similar way to the transformations of shapes, but there's a few subtle differences. So we're going to look at the three separately, and this one is translating graphs. Now, I've got three different graphs to look at here, but we'll just look at the x squared to begin with, and we should see that it applies to all of them the same way. Incidentally, we're on everyone's favourite graphical calculator, Desmos, which is a fantastic free resource, desmos.com. And here I've got them to plot out y equals x squared. And if you want to move, or translate, I should say, a graph up or down the page, then you just add an amount. So if I add 2, it moves 2 up. If I take 2 away, it moves 2 down. In fact, I can change this to a slider, and then we can see that it will just go up. In fact, it goes off the screen, and it will come down, depending on what that amount is. Now that's true for pretty much any graph. You can sort of see the value, if I pause that there, the value of where it goes through the y-axis is always that amount that's added on the end, which is -1 here, and it goes through at -1. But it means that all points are 1, in this case 1 lower than they should be. 2 squared should be 4, but this is plotted at 3 because every point on the graph has been moved 1 down. Now this is the same for all of my graphs, so if we turn that one off and put sine on, we can also add a to this, and we can press play, and it does the same thing. It moves up and down, and in fact off the screen, so we can change this to -6 and 6 rather than having it off the screen. So, yep, this one just goes up and down exactly the same way. It's just adding that number at the very, very end. You do all your working out, sine x, you do that. If you add a number at the end, after doing whatever math you're doing, then that's what happens. And if we go to y is e to the x, exponential growth, which we've heard a lot about in 2020 with COVID and coronavirus. Again, if we add a to that, then just adding that number at the end will make it go up or down, depending on whether that a is a positive or a negative number. And just for fun, we'll put all three of them on at once, and you can see that they're staying together because that's how they would be drawn if I didn't have the plus a on at all, and then the whole thing is moving up and down. So it doesn't matter how complicated your sequence might be, your equation, your line might be all wiggly wobbly, adding a number at the end will move it up, taking a number away will move it vertically down. Well, you might ask, and it would be a sensible thing to ask, can I move things left and right? And yes, you can, but the difference is where you add the number. So here we added the number at the very end. We added it having already done the x squared, having already done sine x and already done e to the power of x. When I'd finished doing the maths that was originally there, I then added the number. And the difference if you want to add it, if you want to move it left or right, translate it left or right, is you've got to put that addition on before you do any maths. So we've got to add it onto the x and then do what we would have done, do the squared, the sine, or e to the x. So in this case, we can change this to be, instead of being x squared plus a, we need to say it's x plus a and then squared. So we're still doing the number squared, but we've just added something onto that number first. And same thing here, we need to say add a onto x first and then do the sign of that number. And likewise, we're going to replace this with e to the power of x, let's not let me do that. Why doesn't it let me do that? We'll just do it like this, a plus x. That will let me type it in. So let's have a look again. Let's do it one by one, and then we'll turn them all on at the end. So what happens with this? Well, now it is moving left and right, which is fantastic. That's what we wanted. Adding the number on to the x first and then putting it in is what we needed here. And we can turn that one off and look at the sign, and it should be doing the same thing. Moving, it looks like a sort of electromagnetic wave. And if we turn on e to the x plus a, then it's doing exactly the same thing as well. It's staying exactly the same, but just the whole graph, the whole picture is moving left and right. And for the fun of it, we'll put them all on. And again, you can see that they are staying still compared to each other because everything is just getting shifted that amount. What you've got to watch, though, is with the moving left and right, it seems to move counterintuitive. When we added 2 at the very end, it moved 2 up. But look, we're adding 4.15, but we've moved left. You'd think it would move right, but it doesn't. It's sort of anything on the x-axis always seems to move the opposite way to the way I'd expect it to. So adding 2 moving up makes sense on the y-axis, but on the x-axis, adding 2 actually moves it left. Well, it does make sense if we put a back to being 0, and we sort of think about it. If we add 1 to this, we're going to say, okay, at this point, yes, at 0, we're not going to plot the value of y for x equals 0, which would be 0. We're going to plot the value of y of x plus 1. So here, we're going to come to x is 1 and get that value, but we're going to plot it here. So it goes to there. So it's in fact moved to the left. So when you think about it like that, it makes sense. Whereas before, we were saying for whatever x value, work out your y value and then make it bigger. So move it up. But here, what we're saying is work out the x value, yes. Sorry, work out the y value, but record here the y value for a number that's to the right. And what that does is it shifts the picture to the left. Now, if that doesn't make enough sense to you, then you just have to remember that when you add something to the end, when you add it to the end of the function, then it's going to move it up. But when you add something inside the function, it's going to move it to the left. Now, we can have both going at once. So we can have, if we turn these off, we can have adding something to the x, which is going to move it left and right, adding something to the end, which is going to move it up and down, and just because it's fun, we can have both on at once. And now it looks like it's moving on a diagonal line because it's moving left. The amount it moves to the left is the same as the amount it moves up, and the amount it moves to the right is the same amount it moves down. If I change this letter to a B and I add another slider, then it starts going, oh, I've not changed those to be different values. It will go in a different way, but it will still make a sort of a, if we press play, it just makes diagonal lines still. It just depends on how I set up this A and B as it moves in both axes in a linear way. Now you might ask, how do we write that down? And we can use function notation to say this. So if y equals a function of x, so you do all your maths on your x, plus a, that's going to move it up by a. If we write y is a function of x plus a, so we're putting the a on the x first and then doing the maths, then that's going to move it to the left by a. And even if it's a more complicated function, let's say that we have y equals x squared plus 3x minus 2. If we want to move this graph up by a, well, or let's put a number out, let's say 5. So if we want to move this up by 5, I can just add 5 to it, and we get y equals x squared plus 3x. If we add 5, we get plus 3. That graph will just be 5 higher. If that's our original one, then it will just move it up by 5. If we want to move it, so sorry, I should have lined that up better. That's the up by 5. If we want to move it to the left by 5, we're still going to add 5, but excuse me, but we're going to add the 5 onto the x, which means any time that there's an x, before we do any maths on it, each of the x's needs to have a plus 5. So to move it left, we're going to say x plus 5 squared plus 3 times x plus 5, and then the minus 2, as per usual. And you could expand the brackets and simplify it and work that out, but my point is just to be careful that if you want to do it with a movement in left and right, then it has to be applied to each x before any maths happens. Other videos will talk about reflection and rotation. Oh wait, no, not rotation. Reflection and stretching. You can't do a rotation as a transformation of a graph, or not that I'm aware of anyway, not for GCSE and A-level. And so we'll do those in other videos, but for now, I'll leave it there. If you have any questions, you can pop them in the comments below, and cheerio for now.